All right, so here we are. We're going to look at this shadow problem, which is similar to the simulation we did in class. So we have this candle and it's shining light at this object over here. And then there's a screen back here behind the object, and the light is going to go, but it's going to get blocked by this object. And since the light's coming in at an angle, it's going to keep going towards the screen at that angle. And the idea is eventually there will be a shadow on this screen that is bigger than the original object. And so in this particular question, our goal is to figure out how big the shadow is. So the key to this is to realize that we can look at this as a series of triangles. So there's a triangle here. The size of the object is 1 is the base of the triangle. And then I'm not drawing in a straight line very well, but this triangle right here from the candle to the object. Now, the new triangle that's created is there's also a triangle. Let me change my color here just so we can see it a little better. So there's another triangle formed because this keeps going all the way to the screen. And this triangle is similar to the other triangle. What I mean by similar is that it has the same general look, same proportions as the other one, has the same angle over here. And what in a similar triangle, everything is proportional, meaning if you triple the sides of this triangle, if you triple all 3 sides, you'll get a bigger triangle in the same proportions. So basically what that means is if we take this distance here, which we're calling x, and the distance from the screen to the candle, which we call y, they're also proportional. This object height and this shadow height, they're also proportional. And so what we can do is we can set up a ratio. And a ratio is basically where we say, okay, if I take x divided by y, and I'm just going to make x the smaller one, so x is shorter, whatever x divided by y is, that should be equal to whatever r divided by s is. They're proportional. So again, if this object is 10 centimeters and this distance is 20 centimeters, if I double my distance to 40, then the shadow should also double. And again, we should have seen that hopefully in the activity we did this week. So let's look at this particular problem here. We're given the distance from the candle is 18. So this is 18. And the distance from the screen is 130. So again, this is not proportional. So this is a much bigger distance than this. So the idea is the farther the screen gets, the longer the time the shadow has to grow. So the object, it says, has a size of 5. So what we're going to do is plug into this proportion. So in other words, 18 is to 130 as, I'm just going to break this up so we don't confuse the two, as 5 is to the length of the shadow, s. Now, s looks a lot like a 5. I probably should have chosen different numbers. So we're just going to solve this to find the length of the shadow. And this is something you'll do a lot in science, solve a type of proportion like this. A classic way to do it is to cross multiply and divide. That's one of the easier ways to go about this. So cross multiply just means 18 times s and 130 times 5. Now 18 times s is simply 18. Oh, that's right, I can't write over there. Okay. 18 s, and it looks like a 5, I'm sorry. And then 5 times 130 is 650. So that's the cross multiply, and the divide, I want to get s by itself. So I divide both sides by 18 to find out what s is. So then s is going to equal whatever 650 divided by 18 is. In this case, it is 36.1 approximately. I am rounding that slightly. So what that means is the length of the shadow is 36.1. And we can double check that by seeing if this relationship holds true. So 36.1 and 5 to 36.1, this is roughly 7 times the size, the shadow. 7 times 5 is 35, not exactly, but close. So this distance to the larger one should be roughly 7 times bigger too. So 18 times 7, well, 10 times 7 is 70, 8 times 7 is 56. Yeah, we're in the right ballpark. So this is just a quick check to see if this works out. So in a proportion, again, if I take this distance and multiply it by 7, then the shadow should multiply by about 7 as well. So again, it all comes down to solving this proportion. And in this particular problem, you're looking for S, but you can do several problems where as long as you're given 3 out of 4, you can find the fourth one. So I could tell you the size of the object, the size of the shadow, and the distance to the object, and you could find the distance to the screen. Or I could give you, the distance from the object to the candle, the screen to the candle, and the size of the shadow, and you could find the object. You can really do any combination of these. So it's really just, again, setting up a proportion, cross multiplying and dividing, and then just checking to make sure your answer makes sense. So try the quizzes on this, see if you get the idea, but that's pretty much the gist of it.